Hello, my name is Dr. Tilina Surasinghe. I'm a professor from Bridgewater State University with the Department of Biological Sciences. We are going to present today about a collaborative study we did in Sri Lanka with respect to the forest cover changes in the dry zone. Um, Now, there's a lot of interest in studying global scale forest cover changes, and those studies have shown that the forest cover changes are much more dramatic in diversity-rich realms like tropical areas, and there are a mixture of anthropogenic human-driven causes as well as some natural disasters like forest fire responsible for these kind of driving these kind of forest cover changes. So um, Millennium Ecosystem Assessment is one of those global scale studies that have studied forest cover change, which suggested about 3% global scale forest cover loss from 1990 to 2015 and 6% 6% loss of natural forest cover. Um, there are a few study limitations in the existing studies. For example, most of those studies have spanned the global scale or global scale ecoregions or done at continental scale. Few studies have been done in the region at a country level, but there are some gaps, particularly in certain developed nations like in tropical South Asia, where diversity is higher. The forest cover change has not been effectively studied, which creates problems in conservation and natural resource management, because without science-based data, you cannot effectively promote conservation and natural resource management. So forest cover change in Sri Lanka has undergone multiple land cover transitions. So some of the drivers that comes up in the literature include plantation agriculture, slash and burn, like China farming, rural development programs, and then interestingly, what happened in the past history with abandonment of hydrologic civilization and reinvigoration of these hydrologic civilizations throughout certain parts of the ancient cities of Sri Lanka. Um, Within the past 100 years, generally we observe a declining forest cover as well as increasing rate of forest loss, right? And um, still, we actually require some detailed study. As you see in my previous point, we have a good assessment up to 2010, right? But we needed to look into analyze these trends, understand where we see most of the dramatic forest losses happening, and use contemporary data and more cutting edge technology in order to do the assessments. So we have three different objectives, and in this study we are going to aim the dry zone of Sri Lanka and study forest cover changes for the last roughly 30 years, produce a forest cover map for 2019, kind of the up-to-date forest cover map for Sri Lanka, trying to understand how and where and when forest cover changed in Sri Lanka between 92 to 2019 in dry zone, and then understand what is driving these changes. So our study area is dry zone, as you see in the map. That's the pink part in the map is the dry zone. This covered roughly 60% of the land area, influenced by the monsoon forest, monsoon rain and monsoon winds. We recognize four different types of forests over here in this particular ecoregion. These are largely lowlands with some residual hills and generally experiencing this dry, warm, tropical, humid climate. So methods we use, we are not going to go into detail. I'm going to quickly go over this. We use Google Earth Engine for the pre-preparation and cleaning up the data. And then subsequently we use several machine learning algorithms to do the forest cover classification with, feed forward kind of training of the machine learning algorithms. And then we pipeline the existing data on forest cover changes to compare from 1992 to 1999, 2010 to 2019, and understand how within those several years, those multi-decades, how forest cover has changed and where it has happened, right? So let's look at the results now. So, right, let me go back. Yeah, so from 1992 to 1999, right? So the red colors you see in this map is actually areas where forest cover loss happened in 1999, or where we documented forest cover losses in 1999 with compared to what we had in 1992. And then let me show you the other comparison from 2010 to 2019. Again, the red color indicates areas where we documented forest losses, right? So what you can immediately see is, of course, as you progress, there are in 2010 seems like there were heaviest forest losses compared to any other year. And in general, if I keep switching back and forth between these maps, what you're going to recognize or realize is that forest cover loss happen throughout the dry zone. It's not endemic to particular areas. There are certain hotspots where forest cover loss dominated, but in general, it has occurred all over the dry zone. And interestingly, it has kind of focused on those smaller forest patches at the fringes of larger forest patches, which actually has really interesting ecological consequences. So generally, what are we looking at over here? From 1992 to 1999, there was moderate amount of forest cover losses. Nearly from 42% of forest cover, we dropped to 40%, right? And from 1999 to 2010, from 40% we dropped to roughly about 39%, and from 39% in 2010 for 2019 we lost about 35%, right? So we actually have some gradual losses in forest cover, right? So here we are actually showing you all the kind of dynamics that we observed in Sri Lanka in terms of forest cover losses. So there are several things happening over here. One, you could get forest gain. The lighter green speckles that you see in these maps are actually the areas that sustain some forest gain. That's actually after abandonment of a particular non-forest area that has been converted to forest through forest regeneration and forest succession. Really interesting phenomena to observe. The red ones are again net forest losses. Dark green is where the forest cover persisted, right? And the yellow is where you had persistence of non-forest land cover types. Now, at a gross observation, regardless of the decades we are comparing, you can clearly see that a large extent of persistence of forest cover in Sri Lanka, which is great news. So some of the conservation actions we have already on ground is working. That's terrific news, right? But look at the areas we circle over here. Those are the areas that actually suffered the greatest amount of forest loss. Like if you look at the North Central, right? The North Central forest cover loss persisted throughout all the decades, right? And certain parts of the Northwest also continue to lose forest cover, and in the recent years we do observe some forest losses happening even in the southern parts, right? Significant amount of forest losses happening in the southern part, right? So generally you can also observe, although there are some forest gains, right, forest losses generally override the extent of forest acreage we gain by forest successions. So as this map shows, the net change in forest cover dynamics is negative, meaning what we observe all the way up to, if you go all the way up to 2019, is a net forest loss, right? The same thing if you try to translate that to annually, right? From those decadal pattern, you look at annually, average it across annually, again we see evidence for deforestation, right? And also interestingly, the greatest forest gain happened in the decade from 1999 to 2010, right? That's actually a significant amount of net forest gain, right? But then of course that forest gain kind of plummeted in the recent decade from 2010 to 2019. And like I mentioned earlier, as a percentage, if you kind of try to average across, right, we are still experiencing, slightly less than 10% of forest cover loss in dry zone of Sri Lanka. So I earlier pointed out that there is some stability of forest cover in the protected areas, and this is kind of this particular image highlights the fact that within forested areas from 1992 to 2010 we have some losses, about 4% forest cover has been lost even in protected areas. But by the way, that kind of forest loss could be attributed to some grassland management, where the conservation authorities try to manage woodlands and forests into grasslands, which is a very important conservation application. The second one could be actually due to removal of certain invasive species that have the tree-like morphology, where we removed the invasive forest-like habitats and converted them back into scrubland, grassland type habitats. So in general, our consensus is in protected areas, the forest cover loss is minimal, right? That's a worst case scenario, is the forest cover loss is minimal. In unprotected areas, unsurprisingly, we have massive amount of forest cover losses, and that loss of forest cover outside the protected area network has aggravated over time, as you can see in the pie charts. So what are our general conclusions in this study, right? So forest losses as a percentage, actually it tantamounts to loss of about slightly over 8% of the dry zonal land area. But we have some forest cover gains, but that amount gained is unstable on one hand. Two, it's actually is not protected, right? So there is actually that problem whether even we gain the forest cover, that's not being incorporated into conservation actions. And the rate of forest loss is increasing. And also, when we look into this interdecadal analysis, we kind of see the forest cover change, although we did mention that the net change is negative, right? Meaning there's forest loss. The change is non-deterministic. It's not direction. Things have been going back and forth quite a lot, right? So the actual forest cover dynamics is quite complicated, at least for the dry zonal landscapes. And it's not happening at the same rate or same way across different parts of the dry zone. So still in Sri Lanka, particularly in the dry zone, we have this agrarian economy that is largely driven by different farming systems. And so rural livelihoods are heavily dependent on forest systems. So that's why we actually will this kind of forest loss is continuing. So within the recent times, 1990 and onwards, the forest cover change actually comes about by combination of multiple factors. The commercial farming with the agrarian industry, right, is actually picking up its pace. It's no longer self-sustenance. There's actually commercial scale agriculture that is driving forest cover losses. And in fact, we do have evidence for that. Most of the areas, hotspots that we see some sort of forest losses, those are more open woodland type forests that are disproportionately suffering more from encroachment and slash and burn. And then continuous infrastructure development, particularly through state-sponsored programs like Mahavira Development, has been massively destructive for the dry zonal forested environments in Sri Lanka. And also, like when the government develops infrastructure in dry zone in rural areas, inevitably that leads to kind of further accentuates further infiltration of people into dry zone, further driving land cover changes. So these infrastructure developmental programs that are state sponsored have contributed to further aggravation of forest cover loss. So and then, like I mentioned, the privatization of the agriculture, right, is actually also responsible for this, aggravation. This recent trends we observe, the aggravation is driven by the privatization rather than from the subsistence-based farming activities. That said, we cannot forget and eliminate the local drivers that are actually happening, like illicit lumbering and firewood extraction, and cattle grazing. These kind of, smaller activities happening at smaller scale should not be neglected. And generally conclusive remarks are actually that Sri Lanka has a successful forest conservation happening. I mean, we see protected areas being largely stable in terms of retaining their forest cover. So it's actually, we have a good framework, right? But we have very poor law enforcement on ground. So we needed to boost that up. And then we encourage to do continuous monitoring, use satellite data, use remote sensing, and do it periodically so that we have a better understanding where conservation actions need to take place. And these things are very cost effective, right? I mean, most of the resources we are using are freely available. The analytical tools we are using freely available. So this kind of research should continue in future to better understand the magnitude, the pattern, trends, and spatial locations where forest cover loss is happening. Um, and yes, we do need to recognize where we need to have more conservation attention. Where do you see the most forest losses happening? And then the state agencies, conservation authorities to need to work collaboratively. The forest department and wildlife department need to have more communication going on. There should be more research that involves the academia of international and Sri Lankan research universities. And in future conservation efforts, we need to consider about large or the non-consumptive value of the forests. That actually particularly includes the carbon sequestration capacity, and also introduce some sort of a eco-friendly livelihoods to the people of dry zone. Right, that's where the government subsidies should be really helpful. Well, with that, I conclude my presentation, and here's a link to the full paper. Please go ahead and read it. We published it open access so that you all can read it. Thank you for your time, and thank you for inviting me for this presentation.